Here we go.
Okay.
Yeah,
All
proceed.
right. So, my name is Jacob Mackey. I'm a senior backend engineer at Big Nerd Ranch, which is a software development company owned by another company called Stellar Elements. And I'm also a Z-Shell plugin developer. Created a project that's based around Z-Shell. It's very advanced Z-Shell configuration, etc. But in this talk, I'm going to talk about Kubernetes, and KS just means K, 8 letters, then S. That's abbreviation for Kubernetes, just like I18N, etc. And there's some styles of put commands like CLI commands in bold and other stuff like that. So Kubernetes, what is the purpose of it? The purpose of Kubernetes is to make your deployments of containers easier and more effective and more reproducible. So it's all based around containers. So without containers, there would be no Kubernetes, because Kubernetes is a layer on top of containers. And it's really all about container orchestration, which mostly means starting and stopping containers at the right time, and managing their life cycle. So for example, if you run a container that has some process in it runs out of memory, well, it's going to crash. And whenever Kubernetes sees that a container is crashing, it will spin up a new container. So that's something like that Docker doesn't do by default, because Docker is just a container technology. It doesn't, manage your containers automatically like Kubernetes does. And another function of Kubernetes is it's going to load balance between your containers. So say you've got a web server and you want to be able to handle a lot of traffic. Well, then in Kubernetes, you could say, I want, 100 replicas of this container. And Kubernetes would take care of, maintaining that number of replicas of that container. So instances of that container image. And then it would load balance between those, like 100 web servers, for example. And another thing Kubernetes can do is it can automatically scale the number of containers. So you can have various parameters. So this would be like horizontal auto scaling, basically, where you're increasing the number of containers based on, CPU or memory consumption, etc., traffic, IO, or whatever. And so that's something that Kubernetes can do, is horizontally, dynamically scale your application. So that's really the purpose of Kubernetes, is to make all of this possible in a way that's, reproducible and stuff like that. When people say Kubernetes is really an API. It's just a kind of like an interface. And there's a lot of different distributions of the Kubernetes API. It's not like it's kind of like containers. Containers is like a concept, and there's a whole bunch of different, technologies that have implemented containers. And the same thing with Kubernetes. So, there's a whole variety of different products, software products that you can go and download, and they're all using the Kubernetes API. So, for example, I worked for Fortune 50 shipper for 3 years, and they were using Red Hat OpenShift. And Red Hat OpenShift is a Kubernetes distribution. It's all based around Kubernetes. It's Kubernetes under the hood. They have, a GUI. I've got this slide here. They've got a GUI built around, Kubernetes API, and they have their own CLI command called OC, etc. but it's all Kubernetes, and there's, every cloud provider is probably going to have their own Kubernetes distribution. AWS has EKS, Google has GKE. There's other standalone Kubernetes distributions like Rancher. Minikube is another one where it's standalone. I'm gonna run that locally. Minikube is good for just testing things and demoing things, etc. So Kubernetes was created by Google internally, internal projects, and it's written in Go. So a lot of times you'll see messages pointing at some Go line number, some Go file. And there's the Google Borg project, which came before it. And Google donated it to the Cloud Native Computing Foundation. So now it's, completely free and open source, stuff like that. So yeah, so OpenShift, like I said, it's a Kubernetes distribution. It's all based on running, your clusters. We'll talk about what a cluster is, but it's all about running your clusters on Red Hat Enterprise Linux, a Linux distribution that is very popular in the enterprise world. And it's got its own cluster manager web application. And a lot of people are using it to deploy microservices. So microservices and Kubernetes basically go hand in hand, because you can deploy your microservices in containers to Kubernetes, and all your microservices can communicate inside of the cluster, inside the Kubernetes cluster, and it tends to give you very good performance, because all this communication between microservices, usually HTTP, but it could be anything. All that communication is happening inside the Kubernetes cluster, and you don't have the overhead of leaving the cluster, going out to the internet, etc., or some other network. And so OpenShift is very popular. I know a lot of companies using that, and it's a turnkey distribution because basically everything's provided for you. Well, when people talk about Kubernetes, a lot of times you can do Kubernetes just with the kubectl command, and you don't need a GUI. So the GUI, the GUI web manager and Kubernetes itself are distinct. So like I'm going to demonstrate some Kubernetes stuff just using Minikube and the CLI. I'm not going to, open up a GUI. So, and containers. Who has questions so far? Nobody. All right. So the purpose of containers are used to isolate applications. So, so you had an application, it's using a different version of Java than another one, and so if you ran both of those, applications on the same computer without containers, you might run into version conflicts, etc. And containers allow you to run as many things as you want on the same port, so you don't get port conflicts, etc. And it just makes deployment much more scriptable, reproducible, fast, simple. Makes orchestration, which is Kubernetes, what Kubernetes does, easier. I mean, you can run 100 Nginx servers in parallel, easily, and you could load balance between them with Kubernetes if you wanted to. And each container is really, it's like its own network host or little computer. It's got its own file system, its own processes, everything. It's like container technology is all based around Linux. So each container could be like a little Linux computer. You'd think a little single board or something, with this, everything's isolated, its own little computer or server. And the default is that all your containers are not accessible. They can't talk to each other, and the outside of the container engine, you cannot communicate with them. So you have to go through steps to enable communication. So a container versus a VM. Container is much smaller than the VM. You don't virtualize the kernel and the hardware. A VM is a full-blown emulation or virtualization of everything, and they're much larger CPU-wise, memory-wise, disk space-wise, etc. Containers are really for temporary deployments that you would start and stop, and a VM is much more of a something that you would create and you would use over a long period of time and stuff like that in general. So Docker, everybody says containers Docker, right? Well, not really. They're not that synonymous. Docker is a container system, but there's plenty of other ones out there. In fact, there was tons of container systems before Docker. Like people were using container technology in Linux for a long time before Docker came about. It's just that Docker made it easy. It made it popularized container technology. And that was really its innovation. It's just easy to use. And when people say Docker, there's the client CLI, there's also the server or the daemon. And you have to, you can decouple those. So like you could use the Docker CLI and you could not use the Docker engine. You could use Podman, for example. That's what I use is Podman. Podman is another container system distinct from Docker, for example. And you could still use the Docker CLI commands to connect to Podman over. So image is a blueprint for container. Container is a running instance of an image, and you can have as many containers for any image as you want, or as your system allows. Image tag is just a version of an image. So Kubernetes. The only reason I talk about containers is because if you don't understand containers, you don't understand Kubernetes, basically. So Kubernetes has a distributed architecture. So there's the control plane, and the control plane is where all of the controlling processes run. So things that like your non-workload stuff. So there's the actual servers that are handling all your Kubernetes API commands. There's a scheduler, etcd, which is a database that basically key value database that holds all your configurations and memory, like persistently. And then there's the worker nodes, and those do they handle all the all the containers that you'd be running in your cluster. So a cluster is a control plane plus the worker nodes, and it depends on the hardware setup, but you could, it could be very distributed. You have control plane running on one server or multiple servers, and then you could have a ton of different servers running worker nodes, right? And they would all be part of the cluster. And, that's a lot of people do that. So the control plane, something you don't, as a user, really interact with directly per se, as in you don't go in and configure things beyond like the porcelain layer of like kube CTL. But actually that's when you run Kubernetes commands, you're communicating with the API server that's in the control plane. And actually all your Kubernetes commands are based on HTTP calls between your client CLI commands and the master process. And I talked about etcd. It's the key value database, persists your configurations. So Kubernetes all based around, configurations. They're either going to come in files, YAML files or JSON files, or they could come in through your kube CTL commands, and all that's going to get persisted in this etcd database. There's the scheduler, controller manager, etc. So yeah, control plane is the main master uh, part of Kubernetes cluster, any Kubernetes cluster. Questions?
Do you have anything coming up that's describing clusters more?
Describing, no, not really.
So my question around clusters is what is their scope? Because usually I've seen them either as like an environment or
Oh yeah.
like a server. Can you describe that a little bit?
Yeah, so environment, I'm gonna talk about namespaces later. But a lot of people, so like cluster can host a variety of different, are we talking about like environments like dev, QA and staging
Yeah,
prod?
so I've usually seen it as like exactly dev QA staging, and they might contain multiple containers. But I'm curious if that is a single that's all running on the same hardware, or if that encompasses like multiple distributed servers.
Yeah, it totally depends on the implementation. So like a lot of times people run different environments on the same cluster and they use namespaces to control which environment things are running in. And you can have like you could have dev, different environments, dev, QA, staging, all of that on the same cluster, or you could have it on different clusters. So it all depends on, whoever's implementing. But a cluster is really, it's kind of like a hardware concept, really, because it's it's not really a hardware concept. It's a software concept, but it's just like a distinct um system of control. It's way above environments. Because you can host a lot of different environments on the same cluster. Cluster is it's kind of like a infrastructure concept, a distributed computing infrastructure concept above any like software like related to a project concept, if that makes sense.
I think I see it. So is it more like just a categorization, or is it like a group of could be more like a group of hardware?
Yeah, it could be it is like a group of hardware because it could be only one server, in which case you'd have the control plane and the worker node on the same hardware, or you could have it distributed where you've got a bunch of different servers running nodes, and then they would talk to another server which is running the control plane.
Gotcha. Yeah, that makes sense.
So yeah, it's very you know kind of like a hardware concept, even though you could run multiple clusters on the same server, but that would be quite rare. I've never seen that actually. So with Kubernetes, the cluster is made of the control plane and the nodes. I talked about the control plane, what that is, and the nodes, that's where all your containers run. They host the workloads. And could be on a different server, could be on the same server as a control plane, who knows? That's up to the implementation details for the particular project. And there's a thing called kubelet, and that controls all the pods in a node. And then you have the container runtime, which is running the pods, and then you have kube proxy, which is forwarding traffic to the pods on a particular node. And a lot of this is you never, as a user, you don't see these details because a lot of that's set up maybe initially by some person setting up the initial cluster, and their host setting up all the nodes, and then all of this is transparent to the developer, for example, because they're not going to be they may not know where these nodes are, where they're hosted, etc. So like I worked for this shipper company for 3 years, and they had multiple data centers, and I didn't, I knew they had blade servers, which I had a bunch of blade servers, but deploying to Kubernetes, I didn't know the actual hardware and where this or that node was, etc. A lot of this is transparent. You don't actually interact with this as a developer deploying your applications.
What's that pod?
So, yeah, so I'm going to talk about what a pod is, but a
Okay.
pod is the basic unit of Kubernetes, the most common thing that you interact with. And it is basically one or more containers that represent like a workload. And so, for example, if you wanted to have 10 pods, that would mean you would have 10 replicas of this set of containers. Usually people only have one container in a pod, but you can have multiple containers in a pod, and that's what these little cubes and cylinders. Oh, the cubes represent the containers. So, you can see here's a pod. It's got one container. Here's another pod. It's got a container and a volume. And then here's another pod. It's got two containers and a volume, and etc. So usually the usual case is you got one container in a pod, and that's usually what people do. And then they say, I want 10 pods of this, whatever web server. And then you get 10 containers, but each one is in its own pod. And the pod is the basic unit of like a deployment. So when you deploy an application, you get a pod. And that pod has your container, right? So how do you interact with Kubernetes? So, well, there's a lot of different ways, but the kubectl is the common CLI command. So Docker has the Docker CLI command, and Kubernetes, it's kubectl, Kubernetes control, I guess. But there's also client libraries. So pick your favorite programming language, and I'm sure there's client libraries for that language to interact with a given Kubernetes cluster. And it's really the control plane you're interacting with via REST. It's all based on REST, and so I said Kubernetes is written in Go, so it's really kind of like a Go web server that's handling HTTP commands via either the CLI or through some library, or it could be some GUI web application. Who knows? So in general, Kubernetes, you can do CLI commands or files to configure things. And CLI is good for experimentation, but for actual deployments, you want to be using version controlled YAML or JSON files in general. I prefer YAML over JSON because it's less verbose. And so say you had a given cluster, you have a given cluster and you want to apply a bunch of configuration files. You basically want to deploy, whatever configuration you have, then you would do kubectl apply -f, and then you could put in a directory. It'll apply all the configs in that directory to your current cluster you're pointing at. Or you can do kubectl apply -f, and then give it a list of files, one or more files. And like I said, you can give it YAML or JSON files. You can configure Kubernetes like that. I'm going to talk about some of these files later. Yeah, so the kubectl command, that's how you usually interact over the CLI. And it's all really just, HTTP REST APIs to the control plane. But, again, that's all really, transparent to the developer, really. And you can look at the API for Kubernetes, but you don't have to. Like, you could technically go and write some code to go and, make a bunch of requests to the control plane yourself. But usually people use the CLI command, or they use configuration files rather than doing all this other stuff. So there's a file called in your home directory called config. So it's .kube/config, and that's where the kubectl command gets a lot of the information on the cluster. So where are you going to be sending, data, etc. And so you can also run kubectl config view, and that's going to give you a bunch of information about the cluster you're currently pointing at. So I said I was going to demonstrate Minikube locally, and that's what I'm going to do. But so kubectl config view, it says API version, like I said, Kubernetes API, it's version. So, they could come out with different API version clusters. So list of clusters and, etc. And, there's different options. You can choose which cluster, kubectl is going to be pointed at. So, you could have a bunch of different clusters and, communicate to each one of them independently, etc. So yeah. So right now I have Minikube running. So I'm gonna demonstrate. I like the more interactive style presentations. That's why I try to do them myself, because I don't like to just look at a bunch of slides, basically. So I'll skip ahead because I'm running Minikube, and Minikube is just a small Kubernetes implementation. So that's, good for local hosting testing. That's exactly what I'm doing. So I installed Minikube. I started it. Actually, I started it with a different command. Let's skip ahead. Where's that? Oh yeah. So this is a command. So I said Minikube start, and then the driver I specified as QEMU2. It's really, this basically creates like a virtual machine to host your cluster. And then I already ran that. So then Minikube status, it's gonna give me information. Kubelet, remember I talked about that. That's running on your node to, in a, controls basically the containers on your node. The API server I talked about this runs on the control plane. And yeah, so I can create a deployment. So like this, kubectl create deployment. Then I give it a name, and then I give it the Docker image. So I already did this command, I believe, so it's going to fail, but I have to make sure that, see, this deployment already exists, so I'll make another deployment. Git pods. So, all right, so I just wanted to make sure that was all set up so that I can demonstrate a bunch of these kubectl commands. So, Kubernetes get pods. That's what I'm going to demonstrate right now. So whenever you have a deployment, you get pods along with it. And pods, again, are one or more containers. And so I have two deployments here. One of them is called Hello Minikube, blah, blah, blah. The other one's called Hello Minikube 2, blah, blah, blah. And each one of those deployments, I have one pod running out of total one. So I specified one replica, and that one replica is running. And you can see the status of the pod is running, that didn't error out or anything like that. And there's been 0 restarts. So I talked about how Kubernetes, it restarts containers that die for whatever reason. They exit, shut down, it's going to restart it. And every time a pod would restart, you increment this counter. And the age, so when was the first time I created a deployment? And that is the default format of output. But you can also do kubectl get pods dash O wide. And so that's going to give me more information. It's going to show me the IP. So inside of a Kubernetes cluster, every pod is going to get its own IP. And that, this 10.244, that's just internal to the cluster, has no validity outside of the cluster. The node, it's going to show me what node it's running on. And, obviously the control plane, in this case, control plane and the nodes are all the same. It doesn't, matter, etc. And you can do it you can put the output in JSON. So in this case, I'll pipe in the less. This is a good format for, parsing out in a script, etc. But you can see all this information about these pods that were created. So metadata, creation timestamp, all this stuff like that. The namespace, I'm going to talk about what namespaces are. But basically Kubernetes, whenever you don't specify a namespace, everything goes in the default namespace. And that namespace, a lot of people use the namespaces to host different projects and different environments on the same cluster. So you could have a namespace for, XYZ dev and a namespace for XYZ QA and XYZ staging, XYZ prod. Usually a lot of people run prod on a different cluster than their lower environments, but who knows? But people use namespaces like that usually. And there's a whole bunch of other information. I'll talk about a lot of this configuration and stuff like that later. But yeah, that's the JSON format. And you can also do YAML format, which is what I like because it's less verbose. It's easier to read. But yeah, so basically a lot of these commands you can specify the format with the -o option. The -o name is useful for script. If you wanted to iterate over all your pods, etc., you could use this.
Jacob, before when you had the wide output, you showed that there was 2 IP addresses,
Yeah,
but you said that they're internal to the pod. So if these were 2 pods running 2 different web apps, how does someone on the outside talk to them if they can't talk? Because those IPs are for internal use.
right. So there's several ways I'll talk about how you can do that, but generally people use ingresses. Well, first of all, there's deployments, but then there's services, and services are what are used to load balance between pods in a given deployment. And then so usually that's how you access the pods is via services. And then if you're outside of the cluster, see that was all internal to the cluster. So, pods communicate to other pods via services. And then if you're outside of the cluster, like a user, then from there, usually people use ingresses to route to different services based on like a path, or you can do temporary port forwarding and stuff like that. And I'm going to demonstrate that later.
Okay, if you're gonna get to it later, then no worries.
Yeah.
Thanks.
Yeah, I can skip ahead again. So basically, where is it? Let me search. All right, so first thing is, I created a deployment, right? So I created a deployment and created a deployment called Hello Minikube. So I have one pod in that deployment, okay? And now I can run this command and kubectl expose deployment, hello minikube, that's the deployment name. And then the type is node port, and then the port is 80. So whenever I run this is going to create a service. And the service, well, it already exists. So I can do kube get services. And the service is responsible for forwarding traffic to pods. So like say you had 10 pods in a deployment, a service, you would have one service, and that service would be responsible for load balancing between those pods. So that's what I just did whenever I ran kubectl expose. And then, so this service is not accessible outside of the cluster. So in my little terminal, emulator Alacrity here, I'm outside the cluster. So in order to access the service, I have to do this. kubectl port forward service / the service name. And then this is the external port. So I just did 7080. And then it's going to forward to 80 on the service. And then the service is going to take port 80 and forward it to one of the pods. I don't know which pod. In this case, it doesn't matter because there's only one pod, but it's going to forward it to one of those pods in my deployment. And then open up another terminal because this is, just taking up the terminal. I can just curl localhost 7080 because that's the port forwarding I set up. So localhost 7080 is going to port 80 on the service named hello minikube, and then that is going to the pod. Hello minikube, blah, blah, blah. And this is just a temporary port forward. There's ingresses and other things for more permanent external access.
Hey, Jacob, quick question on the services.
Yeah.
So does a service usually have a single pod and
No.
Okay, so the service has many pods.
Yeah, so the way services work is that there is a configuration called selector. And so Kubernetes service, it sends traffic to pods with certain selectors. It provides the load balancing apparatus. And so I can I'm going to go to some example configurations. So this is how usually people configure Kubernetes VF, files like YAML files. So in this service file here, you can see kind service. So this is a file describing a service configuration. And there's in the spec, there is a selector here. And in this selector, the key is io.compose.service. And then the value is homebase chat app Slack. So basically what it means is any pods that have this selector are going to be chosen as, load balancing destinations. Guess basically. So the selector is extremely important because it determines which pods get the traffic. And then in your
Network
pod
wrapper for the pods.
What?
So the service is like a network wrapper for the pods so that
Yeah.
external network requests can access
It's
the
not
pod.
just external, it's internal as well. So say you had say you had a Kubernetes cluster and you had, for example, a bunch of web servers, right? And then say you also had an API running in your cluster, right? So for the API to connect to the web servers internally, they would have to go through the service. Does that make sense? So the service is communication between internal in the cluster, between different pods, as well as externally. It's all going through the service.
I sort of follow. So you're saying that if I create two individual pods and they have their own internal IP address, those two can't talk to each other unless they're part of a service?
You can't, like, that's not normally how things are done because that you could do that, use the IP, but you normally don't because that IP is ephemeral and can change at any time. But like if you get another pod, for example, like say your pod shuts down and you got a new one spun up, now that IP is no longer valid. So
So it serves as a,
generally
more
you
of a
never do
permanent
that.
interface for the
What?
pods. That serves as a more permanent interface than for.
Yeah, it's how traffic gets sent to the pods is through a service.
Gotcha, that makes sense. Thanks.
You would never, I mean, you could technically use the IPs inside the cluster to communicate between the pods, but it doesn't make any sense because, you know, the whole load balancing thing, that's one of the benefits of Kubernetes is load balancing. If you start using IPs, well, load balancing isn't going to work anymore. It also isn't going to work whenever your pods shut down or your cluster shuts down or whatever. And then suddenly you got all new IPs. Now everything's broken. So
Yeah, it makes sense.
people,
You wouldn't want to hard code the
yeah,
IPs to
yeah,
point to anything because it's
it's all
essentially
ephemeral.
temporary. Yeah.
Right. So Kubernetes is all about it's mostly for stateless things. Like you don't, if the cluster shuts down or you spin up, say you shut down 10 pods and you start up 10 pods, it shouldn't matter, because like you're not supposed to be using anything tied to a pod because a pod is just a temporary little thing. Does that make sense?
Yeah, definitely.
So Kubernetes resources, everything I'm going to talk about, like all the different objects and stuff like that, they're called Kubernetes resources. Well, objects, okay, objects are created from resources. Resources are the blueprint for all your objects. So like a pod or deployment, that is a resource. And then you would create a deployment object from that resource. That makes sense. It's like you create an instance of a class. In Kubernetes terms, you create an object from a resource. And Kubernetes, there's a limited number of resources by default, but you can create your own resources. So like a pod is like a resource. And it is one or more containers. Usually people have just one container in their pod. And it's kind of like the basic unit of work in Kubernetes. And you can load balance between pods with the service. You can scale pods up and down, either statically or dynamically. And the replica count is the magic control of how many how many pods you get for a particular deployment. So pods are always created from a deployment. So the actual resources of deployment, and then from there you create pods from that deployment. Kubernetes service is another resource, and it is responsible for sending traffic to pods. So based on the selector mechanism, and the service resource provides the load balancing. That's where the load balancing comes is through the service. A Kubernetes config map. Kubernetes config map is a way to externalize environment variables and their values. And you can, for example, centrally control environment variables and then insert them into pods. So a lot of people use this for, things that would change like an API URL or something, like a database URL or something. People will use config maps, and then the config maps will change those environment variables based on, where you're deploying to, etc. Kubernetes secrets are kind of like config maps, but they hold secret data like passwords and secret keys and stuff like that. And you can insert them into the pods, for example, like a database username or password. You would want to have that, definitely the password and the secret. And then that gets inserted into the pod. And then the pod is able to connect to the database or whatever the case may be. So, all of this stuff, all these resources are all, documented, obviously. And so you can go onto the Kubernetes like homepage and you can look at all these different concepts, service, like what I talked about. you know, in all of these terms, you know, like cluster, pods, service, you know, you have to understand these concepts because the documentation is using these terms, obviously. So if you don't understand these terms, you're not going to understand the documentation too well. So yeah, I talked about what Minikube is. What I haven't talked about is that usually a lot of Kubernetes implementation, they have their own Docker registries. So, or their own container registries. And so whenever you build, so like a lot of these Kubernetes distributions, in order to run your own custom images, Docker images, you have to build your Docker image into their registry. So basically, when you create your Docker image, you have to upload it to their Kubernetes registry for whatever, Kubernetes distribution you're using. Like I know OpenShift has its own internal registry. Minikube has its own internal registry. And that's what the purpose of this is you say Minikube Docker env, and it will basically spit out some environment variables that you need so that whenever you do Docker build, it's going to build your image and upload it to the Kubernetes registry. Yeah. So now I'm going to go into the kubectl CLI command. So kubectl is going to interact with my current cluster. So I have Z shell completion for, a lot of this stuff. So kubectl get, now I'm going to put in the name of a resource. So I could say service, I could say pod, I could say deployments, nodes, there's a ton of different resources here. Namespaces, get all the different namespaces. Oh, I'm going to talk about, I talked about the control plane, and actually all that's running in this namespace called kube system. So I say kubectl get pods, that's in the default namespace. So with kubectl, you do -n, and then you pass in the namespace. So the default one is the one I was using before, but if I say kube system, now I'm going to see all these pods that are part of the control plane. So actually, yeah, Kubernetes is, running a bunch of pods that are, controlling your pods. So they're in the kube system namespace. Anyways, kubectl, you can get all your services, get config maps, get secrets, get namespaces, get ingresses. You can delete deployments. I'll delete a deployment, this one. And then as soon as you do that, you will notice I deleted this deployment, hello minikube 2. And what Kubernetes did is it deleted the deployment, but it also deleted all the pods associated with the deployment. So I'm going to delete this deployment here. And now there's no pods, right? So pods are all under deployment, right? So if you delete the deployment, you delete the pods. If you just delete the pod, Kubernetes is going to spin up a new pod, right? So I can demonstrate that. Kubernetes create deployment. Hello minikube. The Docker image is Nginx. Okay. And I have one pod right now. The pod is spinning up. It's not ready. That's why it says 0 to 1 container creating, right? It's run again. So now the pod is running. Now I can delete the pod, right? But what do you think is going to happen? Well, Kubernetes is supposed to be self-healing. So as soon as you delete the pod, it's going to spin up a new one. That's how things work. Get pods. Now I have a new pod. See, it has a unique new identifier here after the name. So that just shows you like Kubernetes, it's going to maintain your replica count. So, you know, if you delete a pod, it's just going to spin up another one. That's what Kubernetes does. So I was gonna try and create a deployment with like 10 pods or something. But just gonna demonstrate if you had 10 pods, you delete one pod, it's gonna, you know, you delete like 3 pods, it's gonna spin up 3 more. You know, it's not gonna, if you say 10 and you delete 3, it's gonna spin up 3, right? So you can delete services, config map, secrets, namespaces, ingress. kubectl port forward, I talked about that. It's just a temporary way to access a service in a cluster. So I demonstrated this already. Except I'm forwarding to different service port. So whenever you do kubectl service, port forward service, so I put in the service name, then I put in the external IP colon, and then I put in the IP, I mean, not external IP, external port colon, and then the internal port of the service, right? So once you go to 7080 on localhost, it's going to go to 8080 on the service, and then the service is going to load balance via the selector mechanism to all the pods. So yeah. Questions? So the recommended way for external access to your Kubernetes cluster is with ingresses, like a permanent way. Port forward is a temporary little thing. Ingresses are the recommended way to do permanent external access, and usually people are using path-based routing. So you would say, you know, you would curl your cluster domain name like mycluster.com, and then you would do slash, and then you would do the service name like slash web app, and then that's going to route all that traffic to the service named like web app, for example, and then that's going to go to your pods. So that just shows you, like, that was what I was trying to explain, is that services are used, like your all your access is going to go through your service, whether that's an external access or between pods, it's going to go through your service. And the service is what provides that load balancing mechanism. Kubernetes, so let's talk about this. Kubernetes namespaces are used to group Kubernetes objects. So a lot of people, they host different projects in different environments on the same cluster. So they would do like, they would have a namespace called, you know, project-dev, a namespace called project-QA, etc. And then they could have another project like project2-dev, project2QA, project2 staging. And all of those would have their own namespace. So kubectl, whenever you do the -n option, you specify the namespace. So like, you know, here I've got all these pods that are part of the control plane in the kube system namespace. So the default namespace is default. That's what it's called. And control planes, blah, blah, blah. And yeah, there's pods for, you know, one of the things that you can do in Kubernetes is basically like DNS inside of the cluster. So for example, if you want to communicate between pods, you would communicate via services, and that service, you can put in the URL, you can put in the name of the service in a pod. So a pod could, you know, curl with the service name to access another pod. And so that requires DNS. So basically there's a pod called core DNS that's running in your Kubernetes cluster that's responsible for resolving DNS names to pods, basically. So that's core DNS. You see that there. etccd I talked about stores your configurations. The API server itself, the controller manager, proxy, and proxy off. It's basically like reverse proxies. The scheduler, storage provisioner, which is important for basically, I talk about volumes in Kubernetes. So say you had a database pod, say you had a MySQL pod running in Kubernetes. Well, the thing is, Kubernetes pods are stateless. Whenever they shut down, all your data is gone in your pod. So what people do instead is you have volumes, and the volume gets mounted into the pod. So, and the storage provisioner pod is important for basically provisioning disk space for the pods, for the volumes. Questions? And this one I already demonstrated. It's just running it on macOS ARM64 instruction set architecture. So Kubernetes, everything's stateless by default, right? So if you want to run a database pod, like, you know, any relational or database or NoSQL database like Elasticsearch, blah, blah, blah. What you do is you mount volumes into the pod, and then you write your data to the volume, and then that gets persisted. So it's just like Docker volumes. There's also a thing called stateful sets, which is kind of different because it's got like, you know, certain sticky sessions where say you've got a web server running in a pod and you want the client to always hit that same web server. You could use stateful sets. I don't know that much about it because I've never really used them, but apparently you can have sticky sessions. Say you had a bunch of things running in Kubernetes and you wanted to look at the logs. How would you do that? You just do kubectl logs. So let's see what pods do I have running. Okay. So I would do kubectl logs, and then I would need the pod name, pods slash whatever pod I want, and I can specify to follow. This would be like tailing the logs of this particular pod. And then I can also do the default, you get 10 lines from the history. You can also do -L in a label. So I wanted to just demonstrate --tail equals 1,000 or something. So that's going to give me 1,000 lines instead of 10. But yeah, so, you know, this is just the Nginx log. So I ran a Docker image. The image was Nginx, right? And I'm just tailing the logs of Nginx, right?
So if you had say you did have a web app that created its own access and error log.
Yeah.
How are you going to check that?
So it depends. Like, this is basically just the standard output of the process, the main process. So in Docker, right, there's an entry point. And so whatever the standard output of that entry point is,
that's what you're seeing here.
Yeah. So if you had some special error log that wasn't getting displayed to the screen by default, is that what you're saying?
Right.
So in that case, you wouldn't see it with kubectl logs. In that case, you could do kubectl exec. Where is it? You can basically, you can attach, well, you don't have to attach, you can attach to the pod, and you could, you know, basically get a terminal in the pod, or you could just run some commands. So you could cat whatever error, file you're talking about.
Okay, so similar to like Docker exec, and
Yeah,
then cat var log name.
exactly.
Okay,
Yeah. So I don't know. I don't know if I thought I had a slide for this, but I don't remember. But you can do kubectl exec -it, then you put in the pod name. Oops, I want to do this. I thought it was gonna. Okay. I put in the pod name -- to specify the end of options. And now I can run any command. So cat, well, I don't know where your log is, /var/log error dog.
yeah, something like that. Yeah,
Yeah. Yeah, so that's how you do it, if that's what you wanted to do. But I can also just, run a shell. You know, so I'm directly inside of the container, right, in this pod.
gotcha. Yep.
So I can see, oh wow, I have very little commands installed.
Mhm.
But basically, usually in a Docker container, you only have one process running, and that's your main process. So that would be like Nginx, And right now I'm root. I can go in the proc /1. How do you get the process name? Man. Okay. Man line. So this was I forgot in Linux, I think command line, CMD line, isn't that the command that was used to start this process? I thought it was, forgot. Anyways,
Yeah.
basically, I'm in a Linux container, right? That's in a pod that's in the Kubernetes cluster, right? So you can run any, standard command that's, in that particular container.
Gotcha.
Okay, so Kubernetes labels are very important. So basically, say that you wanted to, see the logs from, say you had a deployment where you had 10 pods and you wanted to see all their logs, right? All 10 pods, you want to see all of their logs. Then you could set up a label, and that label would allow you to group all those pods and see all their logs together. Does that make sense? So label's very useful, and you do -L label. So kubectl logs -L, then you put in the label. Let's see. -L. I need a label name. I don't know if I had any labels. Say, look for some labels. Yeah. So app minikube, that's a label I have that would enable me to say I had 10 pods in this deployment, and I could use the label app equal to hello minikube to see all of their logs. Let me demonstrate that. App equals, what was it, hello minikube? See? So in this case, I only have one pod, but if I had 10 pods, I would see the logs from all 10 of them. So labels
Okay.
are, you can use labels in a ton of different places. but it basically allows you to group things. So yeah. All right, so the recommended way to configure Kubernetes is to use files, version controls files. So there's YAML files, there's JSON files. I prefer to use the YAML format just because it's less verbose than JSON. And so here's an example service file. So you have the API, Kubernetes API version, V1. The kind, so this is the kind of resource we're talking about. There's only so many resources, right? Limited number of stock resources. So service in this case. Then you have metadata. So this is metadata, it's associated with this resource. Annotations here, you can basically put anything you want here, but you have the labels here. So this is just a bunch of labels that you can use to select this service. Annotations, I use Compose. Compose is a tool to convert Docker Compose files into Kubernetes files. So that's pretty cool. Compose, that's what it does. Then metadata in the name of the service and then namespace. And then you always have the spec key or property, and the spec, what follows after spec is the actual definition of the resource, right? So in this case, I say in the service, there's ports and the name is 3000. It's just the name of the port. And then the port that the service is going to listen on or respond to is 3000. And then it's going to send any data on port 3000 to port 3000 on the targets. So the targets would be pods, right? So in this case, any request to the service on port 3000 is going to get forwarded to any pods matching this selector here on port 3000. So you can have a different, basically external port and internal port in your service if you wanted. And the selector is very important because it controls which pods get this data, right? And so the selector is just key value, right? And this has to match on the pods for them to get traffic from the service. Questions? All right. Example deployment file. So this is for a Slack bot. So basically at work, I wrote a whole application deployed in Kubernetes. It was there was 4 pods. There was for 4 deployments. There's a Slack bot deployment. There was a Elasticsearch deployment. Then there was an API. And then there was the API, it was the Next.js application. So it was front end and back end. And then there was a Elasticsearch GUI web app. So there's 4 deployments, and this is the code from the Slack app or Slack bot deployment. So here we've got the kind of resources, the deployment, metadata, blah, blah, blah. Spec, replicas, 1. So that means I only want 1 replica, static replica, to get dynamic replica counts. There's other configurations you have to do. The selector, match labels, io.compose.service, homebase, chat app, Slack. So that key value has to match the service selector for this pod to get traffic from the service, right? The strategy type, rolling update. Basically, the strategy type is how are you going to shut down old pods and start up new pods? etc. So this is a rolling update. So basically it seamlessly transitions from your old pod to your new pod. Like if you have a new version, it's going to rolling update. It's not going to shut down all your pods. It's going to and then spin up all your new pods. It's going to spin up a new one and then seamlessly transition to the new one and shut down the old one afterwards. And then after that, you have template. And template is basically your pod definition now. So spec was kind of like your deployment definition. And then now after template, you've got your pod definition. So then you have metadata for the pods. So this metadata at the top, line 3 was metadata for the deployment. Line 19, now we're talking about metadata for each pod. So that used to confuse me. Why is there, metadata and metadata? It's because one of them's for the deployment and one of them's for the pods, or however many you have. You have various labels you can use in your pods. And yeah. Then you have another spec. So this is the spec for the pods. And inside of there, you have containers. And inside of there, you have, usually there's only one container per pod, but it could be multiple containers. In this case, there's only one. And you can see down here, the image. I don't know if you want me to zoom in, but the image name is here. This is the Docker image that it will use for the pod. The name of the pod, the ports on the pod that are going to be, open, the protocol, the resources, the CPU and memory resources or limits for the pod. Restart policy always means Kubernetes is always going to restart the pod if it dies. There's other policies. There's environment. So these are, you can set environment variables here for the pod. You can, in your environment section, you can reference secrets like this mechanism. So I can say the Slack app token is going to come from the secret file. It's the secret file named home-based chat app secrets, and the key is going to be Slack app token, etc. And then I have another environment variable called web app URL. And the value is here. So all these environment variables are going to get created in all the pods from this deployment, right? Image poll policy, I'm not going to talk about that. But yeah, basically there's different ways of, depending on newer images and blah, 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 whether it's going to basically start or stop pods based on the newer image, etc. Another deployment example. So this is so this was a Slack app or Slack bot running on port 3000. Basically, it was with Slack, you can create applications and then you need a bot, code that's going to basically respond to all your commands inside of Slack, etc. So that's what that was. And then this is a Next.js application. So basically a React, it's JavaScript based or TypeScript based. It's got a React front end and a back end, as well bundled in there. So this one, you've got kind deployment, metadata, blah, 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 spec. So in this case, I have 2 replicas. Selector. This is a different selector, right? Because I have a different service. So this selector needs to be different so I can match up the pods with the service. Template, blah, blah, blah. Oh, this is, okay. Spec, so spec containers. In the containers, I have a different Docker image, different name for the pod. I've got a different port. It's going to be open on the pods, and I've got different environment variables. So in this case, I have the Elastic. So this particular Next.js application was communicating with Elasticsearch, another pod. And so it needed to know the Elasticsearch username and the Elasticsearch password to communicate. So this is referencing those secrets. And the secrets will be read and then store these environment variables in the pod. And then I have an Elasticsearch URL. So Elastic URL. And this is actually demonstrates the concept of DNS inside of Kubernetes. So I talked about that core DNS pod in the control plane. And what that allows you to do is that this environment variable has the name of the service right here in the URL. So HTTP. So normally inside of Kubernetes, communication happens HTTP only, no HTTPS. And so you do HTTP : / the service name, and then the port. So that communicates between this Next.js pod and the Elasticsearch pod via core DNS and services. So that demonstrates what I was talking about, where you have a service, and that is used to communicate between pods in different deployments. Kubernetes secrets. This is an example file of some secrets. So, you've got kinds, that's kind of resource, kind, secret, metadata, the name of the secret, type, opaque. You can have different types like base64 encoded and blah, blah, blah. And string data, key and value, right? Etc. So Elastic username, that key has to match this key over here. Otherwise, you won't get the secret in your pod. So, yeah. This is demonstrating different types of secrets that you could have. Just a little table here. And then volume. So if you have a pod and you like a database pod, so I talked about Elasticsearch pod. So if I want Elasticsearch pod, I want to save data, don't I? That's the whole point of a database, is to persist data. So normally in Kubernetes, everything's stateless. So that means, well, I'm going to lose all my data whenever my pod shuts down or the cluster shuts down. So that's not really acceptable. So in Kubernetes, you need to have a volume. And to do that, you need to have a volume claim and a volume object. So the two resources over here, configs kind persistent volume claim, various metadata, spec access mode, modes read write many. So I can read and write to this volume as many times as I want. And then the size. So 1,000 megabytes or a gigabyte. And over here, I got a persistent volume. And the capacity is, gigabyte. The host path is ES data. And forgot the name of the persistent volume and persistent volume claim, I think have to match. Have to look that up, but basically ES data, this host path is important because it's like the name of the volume on your local storage. And so you would mount that into the pod. So you would have a volume mount, and the mount path would be here, user share Elasticsearch data. And that's going to be inside of your pod where your data is mounted. And then the name ES data has to match with the persistent volume name. Questions?
Yeah, I have a quick question on volumes. I'm guessing this is not a concern, but like what is there anything that has to be configured for the event where a database pod shuts down while the volume is being accessed, or does that situation usually resolve itself? I guess I'm curious if that scenario corrupts data at all.
No, I've never seen that corrupt data. I mean, the pod, I mean, before it shuts down, it should be cleaning up and shutting down all its file descriptors. If
Gotcha.
if that pod like catastrophically stops, I guess there's a possibility that data could be in the volume could be corrupted. I don't know.
It sounds
But
like there's a process for gracefully shutting down the process, a database server or whatever, before actually shutting down the pod. In most
yeah, I mean,
cases,
that would be the normal case, like if it died from a out of memory or something, that pod, and it had some open file descriptors, or it didn't sync all the changes to the volume. I guess there's a possibility of corruption. I don't know, but that's kind of like outside the scope of Kubernetes, I guess, at that point.
yeah, that
Now,
makes sense.
now you're talking about, the actual application inside of the pod is not, that's the problem there. So, but anyway, so basically once you have a volume, you could have, a million Elasticsearch pods, and they're all accessing the same volume, right? So they all have the same data. Does that make sense?
Okay, so that volume doesn't have to be in a specific pod. It could be shared across pods.
Yeah.
Okay, that was going to be my question, but you already answered it.
Yeah. So you could have 20 MySQLs, and they all mount the same volume, and then you load balance between 20 MySQLs, and they all share the same data. So, and you can mount any volume in any pod. So you could have your database data mounted in your web server. Who knows? I mean, whatever. So volume mounts are how data is persisted with Kubernetes in general. And that volume inside, that's like, it's kind of like Docker volumes, where it's somewhere inside of Docker and you don't know where it is. And that's kind of like the same with Kubernetes. It's got this volume called ES data, and like where it is actually located on the server, like for example, your laptop in this case, I don't know. So a lot of it's just, it's somewhere, but like Kubernetes is hiding where that is. You know what I'm saying?
I'm too familiar with Docker doing it because I have like a really big volume for Oracle
Yeah.
database, and I
Yeah.
ran out of disk space. I was like, where is this file
Yeah.
or this
Yeah.
volume?
It's
Where
hard
is it?
to, yeah, it's somewhere on your drive, but it's hard to know. You got to go search for, you know, where it's actually storing the volume. And
Yeah.
yeah, I mean, it could change with every different Kubernetes implementation. And then last thing is talk about ingress. Example ingress. So again, API version, kind, ingress, metadata, spec. So obviously you can see these resource definitions are quite formulaic. It's almost always the same: kind, API version, kind, spec, metadata, spec, right? And the spec, ingress class name, rules, HTTP, path type, prefix, backend, service, name, test, port number, 80. So basically, if you go to the cluster URL, like mycluster.com/test path, it's going to redirect all traffic to the service named test on port 80, right? So that's generally how people do external access to Kubernetes ingress. And the whole point of path-based routing is that you can have HTTPS certificate for your cluster. So generally, I'm just talking from 3 years of working for UPS. So what they did is they had a cluster HTTPS certificate, and then that would handle all HTTPS encryption to the cluster. And then they would use path-based routing to forward traffic to the, certain pods that like APIs and stuff like that. So the whole point of path-based routing is you only have one HTTPS certificate on your cluster, and you don't have to, and that secures all your pods basically behind that, inside of that cluster. So like I said before, inside of the cluster, you're going to be using HTTP, not HTTPS. Whenever you access your cluster from external, now you're going to use HTTPS, right? So your traffic to the cluster is encrypted, and then once it gets inside of the cluster, it's no longer encrypted. And the whole point of that is that it's much faster between pods because encryption has overhead. You don't want to be encrypting inside of a Kubernetes cluster because now you're just going to slow down all your communication between your microservices. And I was working on applications for UPS, and they had, 200 microservices per environment, and they would have 6 environments, so it's like 1200 microservices on a cluster or whatever. And you don't want to be encrypting all your data between pods. That's just stupid. So like one of the guys, he came on the project and he started putting HTTPS in a bunch of these environment variables. It's like, no, you do not encrypt inside of the cluster. You only use HTTP and then the service name and then the port. That's how you communicate between pods.
That's pretty cool.
Between services, really. But anyways, so
That tip on certificates is good too, because I know what we go through here. Whenever they have to do a certificate rotation, the DevOps guys cringe because there's so many VMs or compute nodes they have to do those certs on, and I guess this is one of the reasons why they try to push towards using Kubernetes is
yeah,
that they don't have to worry about patching a VM or a compute node, and they don't have to worry about the certificate.
yeah,
That
I
makes
mean,
sense.
Kubernetes, like in general, for most modern software deployments, Kubernetes is the answer for almost very high majority of like use cases. So I mean, you would be, it depends. Like if you have a very simple deployment, you would never want to scale the number of pods and stuff like that. Then I guess you could use Docker Compose, but in general, most people are, load balancing and scaling and all this stuff. So everybody, people are using Kubernetes to do all that because it's already, everything's already implemented for you. And I didn't talk about Kubernetes auto scaling, horizontal pod auto scaling. This is a really cool concept in my opinion because you dynamically determine the number of pods, which is pretty cool in my opinion. But looks like I'm going to see some configuration examples. But there's a lot of stuff you can do with Kubernetes, and I barely scratched the surface of what you can do with Kubernetes. Like I'm doing kubectl get, I hit tab, and look at all these different resources. So basically I only talked about pods, secrets, config maps. What else did deployments.
The secrets, can you use secrets outside of the Kubernetes one? Like for example, we use HashiCorp's Vault for our secrets? Is there like an interface between Kubernetes and Vault?
Yeah, I mean, I'm sure there is. I haven't deal with that, but I'm sure there's a lot of different ways you can do things.
Yeah.
I know, so I know, like, I talked about how Kubernetes has a internal registry. And when I was working for, UPSD, basically they were using the internal registry for some time. And then they switched to JFrog Artifactory over time because they wanted to be able to host their Docker images there.
Mhm.
And so, and I helped them, there's different OpenShift versions, and we were setting up everything to pull all the Docker images from Artifactory and not from the internal registry anymore. And so there was all these processes. Basically, Kubernetes, there's build pods. I didn't talk about build pods, but there's deployment pods and there's build pods. And build pods are basically like containers, but they're used to build your Docker images. And so they were basically in their build pods that were pulling down they were pulling down base images. Like in a Docker file, you know how you have the from clause, and that's your
Mhm.
base image.
Yep.
So they would pull down the Docker image from Artifactory in their build pod, then they would run through the Docker file, right? And build a new Docker image, and then they would push that to Artifactory. And then in their deployments pods, they would pull down that image from Artifactory. And then all of that had to be authenticated, right? So then you had to inject all these authentications. Basically, they would do all this stuff where they would have a secret. So basically with the secret, it doesn't have to be key value. You can actually inject a secret that's a file. And so they would inject files into their build pods that were basically having all the configuration authentication for Artifactory, stuff like that. But there's a ton of stuff you can do with Kubernetes. Like I said, I just scratched the surface, you know. Um, there's incredible amount of configuration. There's also Helm package manager for Kubernetes, and you can create your own resources. I just talked about some of the built-in resources, but you can create your own resources in Kubernetes, and there's all these different packages. I'm sure there's something here for HashiCorp. Oh, it's called Terraform, right?
Vault.
Oh, Vault.
Yeah. They have Terraform also, but the Vault is
Okay.
where you store
Yeah.
your stuff.
Here you go.
Yeah, there you go. Look at that.
It's already there. It's already built.
Oh, good. So I don't have to write it.
Yeah. Yeah, there's a ton out there. And then let's see, what else were they using? I'm trying to remember. There's also a bunch of things you can do to set up clusters from code. So you can write a bunch of code that will set up like infrastructure as code, you know that concept?
Yeah, like
So
Terraform.
right. And there's I'm trying to remember what the name of this program was, but they were doing that with their Kubernetes clusters. I remember they were writing a bunch of code, and it would go and spontaneously create all their Kubernetes clusters and like all their worker nodes, like do everything from like a code file. Oh, I'm trying to remember what that program was. Argo CD. That was it. Argo CD. This was it. Yeah, it was really cool. So they weren't even writing code. They were literally using this GUI program to go in, uh, create all their infrastructure. It's crazy.
CD. I looked that
Yeah,
one up.
Argo CD. Yeah, that was pretty cool because I was working with Red Hat for like a year and they were doing all this stuff. They were basically migrating different OpenShift version, and then they were using Argo CD and Artifactory and all of these. That's when I got really familiar with Kubernetes configurations and stuff like that, because basically OpenShift is Kubernetes and the configs are identical, really.
All right, so now, Jacob, it's time for the obligatory question. Do you use ChatGPT 4 when you build this stuff? Are you a user of ChatGPT 4?
So ChatGPT, okay. OpenAI is the company behind ChatGPT, right?
Yeah.
So I was using some of their APIs, but I was not using ChatGPT, the product itself. So the answer is no, I'm not a user of ChatGPT. But I am a user of OpenAI.
Interesting.
Yeah,
I don't use
OpenAI.
ChatGPT 4 either, but a lot of people are using it.
Yeah, OpenAI, ChatGPT is a product of OpenAI,
Sure.
but I was using, well, they have different models, LLM models.
Yeah.
And so I was using different LLM models, but I was also using Llama. Have you heard of Llama by
Yeah,
Meta?
that came from Facebook, right?
Yeah, so there's different, now we're on a completely different topic, but Llama 2, so basically there's different LLM models and Llama 2 is one of them, right? But actually there's Llama 2, there's 70B, there's a whole different
Yeah.
different ones. And so like Hugging Face, I don't know if you're familiar with Hugging Face, but
Yeah.
it's a place where you can host models and data sets and stuff like that. So if you go on here and you can look for all these different LLM models, and these are all like, I don't know if they're all open source, but I know Llama 2 is open source, but you're not going to find like GPT's model, OpenAI's models on here because those are all closed source. But basically you can choose whatever model LLM you want to use. You don't have to use OpenAI's models.
Okay, so you've been using like LLMs?
Yeah.
Oh,
Yeah.
okay.
And so
Yeah, do you find it helpful?
that
in
was just a company
Kubernetes?
product I was on. I wasn't judging it like that.
So you don't use it for things like how do I do this thing in Kubernetes?
No, I haven't really done that. No.
I have an example. So like I was interacting with someone who I was basically telling them what I wanted to do. So the Elixir interpreter IEX,
Yeah.
you would put in these commands, and I wanted a command history. And I sent my thoughts to somebody, and he had ChatGPT 4 read the document. And then he said, how can I make the author of this post happy? And it suggested a library called RL Wrap, which is like a read line wrapper written in.
Yeah, I've used that a lot. Yeah.
Yeah, and I was like, oh my God, this is what I needed.
Yeah, RL wrap is, I use that all the time because it adds like the read line, key bindings on any
It saves it to a file, right?
it just uses the GNU read line like configs like in the input RC.
Hmm.
That's what RL stands for, is read line, GNU read line.
Yeah.
So GNU read line is a library that provides a standard set of key bindings and it reads the input RC file. So you can put all your key bindings in input RC. Actually, Bash uses the GNU read line by default, by the way. But a lot of these programs like the IEX, I don't know if IEX uses it. I'm assuming it does. But yeah, you can configure stuff in the input RC.
Are you talking about like the Emacs convention where you can do Control A, Control E?
Yeah,
Okay.
yeah, so that is coming from GNU readline, so it offers you the default mode is Emacs,
Uh-huh.
and it offers you like Control A, Control E,
Yeah.
Control like those type of things. That's all coming from GNU readline.
Yeah, but so how does that? We're off topic, but what? So
That
why do you use RL wrap? So
to,
do
to
dash A,
enable
that's the trick.
you to use the Emacs like key bindings in any REPL, basically.
Okay, if it didn't exist, I got you. I got you.
Yeah, it adds a wrapper. That's what it says.
Yeah.
Read
So
line wrapper.
what I was using it for IEX is you put a dash A there, and it'll start tracking all of your commands and save that to a file
Oh, okay.
in your home directory. So
Oh, okay.
if I wanted to persist a session, I could persist a session, all the history, and just throw that into an Elixir file. So I can
Yeah.
like see the session's history. I don't know.
Yeah. Yeah, it does
But
persist the
ChatGPT 4 got me to the spot where I was using it. Even though I didn't use it, someone else, I used it vicariously through someone else.
Yeah, it does maintain a history. So like this closure command REPL, it doesn't, I'm pretty sure it didn't persist the history without RL wrap. That's why I used it. But anyways. So yeah, I mean, Kubernetes is pretty much the gold standard as far as deployments, has been for a while. So
So
I
do,
have
so go ahead, Ryan. I'll ask after.
I have one more question. I think it was on the ingress,
yeah,
the routing thing.
yeah.
What's the standard for like assuming we're doing web servers? What's the standard for processing those initial requests, or is ingress like actually behaving as your web server router? I guess I'm trying to figure out, like, do you have like an Nginx or some other server that takes a request first before it hits Kubernetes? Just trying to understand what that architecture might look like.
Um, I've seen it done that way, yeah. Um,
So you have a route that hits ingress, and it's so if it exists like you were showing before, it'll route to
Yeah.
that cluster. But what happens if it doesn't exist? Does it know how to generate like a 404 or some other response? You had a
I
non-existent
think it depends on your Kubernetes implementation, so I believe it will respond with a 404. Like there's the kube proxy pod, I believe, that handles that type of stuff. I have to, I know what you're talking about. Like you would set up an Nginx pod and then from there it would forward.
Yeah,
to
just something that just an initial web server to handle all
You could
traffic.
do it either way. You could do it, that would be your choice. Cause you definitely could just forward everything to a reverse proxy pod, and then from there you forward to the appropriate pod or service rather. Or you
Gotcha.
could use the built-in ingress mechanism to do it. So what I've seen is people just using ingress to go to a service, basically. They weren't going to like Nginx, something like reverse proxy, but you could do that. Would be all it's so flexible, you can basically do anything you want. So I don't know, like with the built-in ingress, what the actual how it's actually handling things. Like I haven't done that much research on how it's actually like what pod. I thought it was the kube proxy, but I'm not really sure, and I don't know what's actually happening inside, like, get what I'm saying? A lot of that stuff is just hidden from you.
Mm. Yeah,
So,
I've just seen some like web servers where
oh, here you go. So it says you must have an ingress controller to satisfy ingress. So here's an Nginx ingress,
okay.
Nginx. So you definitely like what you're
Something on
talking
top
about.
of that, like it's just the initial, I guess they're calling it a controller.
Yeah, ingress controller, and then from there, I'm sure you can configure it to, rewrite or whatever you're gonna do, basically. So
Yeah, it's cool. Like I'm envisioning like a service with an API, for instance. You might have something with an API version 1, and maybe you have that pointing to a a certain cluster, and a V2 that might point to another cluster. But if you just hit it with uh, something random, non-existent, then they won't even hit your web servers within the cluster at all. It'll just
yeah, I
get
think
handled
I
by
think
this
you can do a
external one.
wild card though. I believe you could do like a catch-all in your ingress. Like, is that what you want to do? You want to catch everything that's not already listed. You want to go to your reverse proxy, basically, right?
Yeah, I guess that's what I'm thinking of, is just
Like a wild
like
card kind
a
of.
wild card catch, just like catch
Yeah,
all.
you should. Yeah, like you definitely can use wild cards in your you know ingress, and you should be able to do what you're trying to do here. See, paths. See, you can use wild cards, and so you can basically do a catch-all and stuff like that.
Yeah, sweet. Thanks.
Yeah.
They thought of everything.
Yeah, I mean, that's the benefit of leveraging somebody else's technology, and all these people are using the same technology, so almost every possible thing you could want is basically impossible or already existing, or there's
Okay, so
some.
the true measure of an expert here. Um, why is Kubernetes bad?
That
Tell
was
me,
that was my question. You stole my
tell me the
question.
dirt.
Um, I mean, there's a lot of configuration you have to write. So that's a disadvantage for sure. I mean, all of those config files. And it's also very complicated, especially with the RBACs, like the role-based authentication, very complicated. So if you don't need that complexity, then why would you even bother?
Is speed ever an issue? Or it solves
Oh,
it that's what it solves. It gives you speed.
yeah, it gives you lightning speed inside your cluster.
Yeah, okay.
It's perfect for microservices.
There was a banking app that I used that they had a terrible launch. They got rid of their old app and they had a terrible launch. And when I finally logged in, they had an error message that was leaking their K8 secrets.
Yeah.
This wasn't ViStar, was it?
Yeah.
Yeah, I had problems too. Actually,
But I had a screenshot. They had all their secrets for their clusters in the window in the error message they were giving me back after they logged me in.
Like that sounds secure.
Pretty bad.
But I messaged someone who noticed it, and he's like, "Dude, they got bigger problems right now. Like, people can't log in. It's like people can't access their money. Like, I don't know."
yeah, that's got to go down as one of the worst upgrades in history. I had to actually call. I think for 2 months I had to call in and to pay my bills because I pay everything online. But I mean they were nice and they handled it. They handled it fine.
I
Yeah,
would
their whole
call
QA team should be fired.
Yeah, exactly.
the QA team.
What QA team? Code
They
and production, right?
yeah
I was
they still have a bug, Mike. Uh I had paid off my car loan right? But it kept showing like there was a 20-cent balance. And I would try to pay the 20 cents and it wouldn't let me. I tried to pay 15 cents and it wouldn't let me. So I thought, oh, okay, well, this is just a bug on their end. 2 months later, they call me and they're like, you haven't made a payment on your car loan. I'm like, I paid my car loan off. She's like, yeah, but you got a 20-cent balance. I said, I've tried several times. She's like, yeah, it's a bug. Can I just, get your verbal and I'll take care of it? I said, yeah.
I need to really monitor my account. I mean, they could totally be taking money out of my account. I have no idea.
Yeah, they could be doing Richard Pryor and Superman on you.
Something like that. Okay, did we record it? Did the recording stop?
I'll stop it right now. We done, right?
Yeah.
Okay, I'm gonna stop recording.